Hello everyone. This is the final video in a four-part series on physics-inspired low-light enhancement for smart vision on the edge. Today I'll be presenting a tutorial on how to install and run the PhyCV CUDA repository for use with the Jetson Nano. In order to make sure you can follow along, please navigate to the PhyCV CUDA repository either by using the QR code or URL specified below. As you can see here, I have the PhyCV CUDA repository on my left window and my VS Code environment on the right side. Now before I get into the repository, I want to mention that I'm currently connected to my Jetson Nano through my VS Code terminal via SSH. Now all the software setup steps that I'm going to go over in a minute should work fine even if you are not connected via SSH and instead have a display connected directly to the Nano. However, if you do want to emulate my SSH setup here, you will need to set up X11 forwarding so that you can actually view the output image and videos from the Vivid processing on the display that's connected to your local machine. So just make sure you set up X11 forwarding if you are using SSH. Now with that in mind, let's skip over this first part of the README and start with the installation instructions. So I'm going to create a new folder called test1 in which I'm going to clone the repository. And the installation instructions are fairly straightforward. Simply copy these three commands from the README into your terminal. All this does is clone the repository, switch into the repository directory, and then build the project using make. Now this process will take a minute, so while this is compiling, I want to talk a little bit about the structure of the repository and where you can expect to find the code. So our folder structure consists of assets, which are just some sample input images and videos. Our includes are our header files, and the source contains the source code of PhyCV CUDA. Now specifically, I won't go over all these source files, but I want to talk about the vivid.cu file. Here, this file contains the actual implementation of the Vivid algorithm in native C++ and CUDA. If you don't want to view the actual implementation and are just worried about the interface, the vivid.qh file details that interface, which basically specifies a constructor and a run method passing in an OpenCV matrix so that you can run the algorithm on any matrix representing an input image. Now that our project is finished compiling, let's run some commands. So running the default executable with no options produces this output, where we just have two windows, one with Vivid enhancement and one without Vivid enhancement, that are running on the live video feed from a connected USB camera. It is important to note that this will not work if you do not have a connected USB camera. So make sure you connect your USB camera before running the default executable. Now using the -r flag, we can specify the resolution of our frames and adjust accordingly to whatever specifications you would like. For example, if you'd like to use 720p, just type -r 1280, 720, and you'll see an updated scaling over here. Additionally, this repository supports running Vivid on input images and video files. To do this, you specify the -i flag for images and the -v flag for videos. Following the -i or -v flags respectively, you should specify the file location of the input image or video that you want to run Vivid on. Just to showcase this, I have a sample command here that I can run. That shows the before and after of running Vivid on this darkroad.jpg image file. And similarly, if we specify the -v flag, we get the side-by-side input and output for our video. I should also note that if you would like to save your video to disk, you can use the -W flag, but since this induces some latency, the on-screen display is turned off whenever you use this flag. Also, since the Vivid algorithm has parameters, we have included functionality to modify those parameters as you see fit. The default values are specified in the options header file, which can be found here. It includes options.hpp. There's this parameter struct, which contains the S, T, B, and G default values, as long as some short description detailing their effect on the output of the Vivid algorithm. So make sure that if you want to mess around with these parameters, that you check out this description in this header file. Now finally, here are some miscellaneous other options that we have also specified. Vivid-H will bring up the help menu, which gives a detailed explanation of all of the options. Object detection can be enabled with the -D flag. Timing information can be enabled with the -T flag, and Vivid Light can be enabled with the -L flag. Now finally, in order to make sure that you can build and run the library correctly, you need to make sure that you've installed Jetson Inference. If you haven't installed this program, the library will not build. The instructions for installation can be found here, and once you have set up the software, everything should work perfectly with PhyCV CUDA. This concludes the tutorial. Thank you all for listening.